Why do we have gas laws and we don't have liquid laws, we don't have solid laws? We already said that matter is what now? Divided into three states, solid, liquid, or what now? Or gases. How come we have gas laws, especially in chemistry, and we don't have liquid laws, we don't have what now? Solid laws. Because gases behave very differently from what now? From liquid and what? And solid. So let's check out some of the properties. Properties of solid, liquid, and what now? Gases. Shape. Gas not fixed. Liquid takes the shape of what now? Container. Solid has fixed what? Shape. Volume. Gas does not have fixed volume. Liquid has fixed volume. Solid have what now? Fixed volume. Compressibility. You can compress gases. You cannot compress liquids. You cannot compress what now? Solids. Coercive force. Coercive force in gases are the least. It's moderate in liquid and greatest in what now? In solid. Kinetic energy. What is coercive force? The force holding what now? The particles what? Together. That's the reason why the solid particles are more compact than what now? Than gases. Gases are far apart. Kinetic energy is greatest for what now? For gases. And what now? Least for solid. Hence, the particles of gases are free to what now? So move about what? Haphazardly. While that of solid can only what now? Vibrate at what? Fixed position. Do you understand? Then that of liquid is free to move about within what now? The liquid. If you leave a gas, the gas will move everywhere. If you leave a liquid inside the container, the particles, let's say this is the container, and they are liquids. This is the liquid inside. Particle from here can move anywhere inside what now? The liquid. They are free to move about within what now? The liquid. But if you say solid, a particle that is here will always be here, will only be free to vibrate what now? At this what? Position. Not free to what? To move about. Why? Their kinetic energy is what now? Is the least. Is that right? Kinetic energy is energy for motion. Are we together?
Yes, sir.
We use this as an example to explain vapor pressure. There's water inside this container. If I open it, it's not a confined space. But now that I've locked this what now? Confined space. Why is that? Nothing can what? Can enter. Anytime a liquid is put into a confined space, two things must happen. Evaporation will what now? Will take place. And what? And condensation will what? Take place. I've said before that what now? Evaporation occurs at all what? Temperature. Below the boiling water. Exactly. So we don't need to heat this evaporation block now. Immediately you just open it. That's why sometimes when you open your container, it's droplets of what now? Of water. Sometimes you even see droplets of what now inside the container. This is where I'm going from. As long as this is true, if this is the liquid, I'm using this as confined space, now this is the seal. What will happen? Does what? Evaporate now? Is that okay? And while liquids what now? Evaporating, what will happen? The gas will also be what? Condensing. Are you getting it? At the beginning, the evaporation more than what now? Than condensation. Because at first, this place was just what now? Air, whatever is there. The liquid goes up after a while what now? Coming back into this place. Then the time is going to come where what? Evaporation will be equal to what now? Condensation. Yes, sir. And we have said before that pressure is what? Pressure is force per unit what? Area. The force per unit what? Pressure cannot exist without what? Collision. As long as the particles are what now? Are evaporating, they'll be colliding with what? One another. And the wall of the containing what now? Vessel. So in this space here, pressure is what now? Exerted. Do you understand? Now the pressure that is exerted by the vapor at this state, where evaporation is equal to what now? Condensation, is called the what? The saturation what? Saturation vapor what? Pressure. For that particular what now? Is that okay? A time is going to come, evaporation will balance what now? Condensation. But as you increase the temperature, you also cause what now? An imbalance. Are you getting it? If you increase the temperature, there will be more of evaporation than what? Than condensation. Until another what now? Equilibrium is what? Established. And as you go on, a particular temperature is reached where the saturation vapor pressure is equal to what? Atmospheric what? Pressure. At that temperature where saturation vapor pressure of this liquid or this system is equal to atmospheric what now? Pressure. What will happen to this liquid? Start boiling. Do you understand? Boiling will only occur when what now? The saturation vapor pressure is equal to what? The atmospheric what? Pressure. And then the gas can escape, the liquid can escape from what now? from every point. Are we together?
Yes, sir.
Are we together? Okay, there are two factors that affect saturation vapor what now?
Pressure.
For this system. One is what now? Temperature. The other one is what? Nature of the liquid or what now? Cohesive force. Is that right?
Yes.
The minor of boys. All the boys lost it. And the volume of the given mass of gas is inversely proportional to what now? To its pressure, provided temperature is what now? It's constant. We've talked about proportion before. If I tell you that V is inversely proportional to what? To pressure. What does that mean? If I increase volume, what will happen to pressure? To decrease. If I decrease volume, what will happen to pressure? What will increase? That's what it means. The inversely proportional is that one quantity is going up, the other what now? Comes down. One is coming and the other what now? Goes up. How is that true? I will explain. Use this system to what? To explain that. If I have this volume, this volume, this volume, there are three different what now? Volume. And I have 6 particles. Say giving what now? Giving mass. The same number of what now? Particles. Here and what now? And here for the gas, right? What do we say pressure is? Pressure is what now? A result of what? Collision, right? It's going to be very, very clear that the particles in the smallest volume will collide faster than the particles what now? This one will have the greatest collision. So what now? Least collision. So this one that has the greatest collision, what happens to the volume? What is what now? Smallest. Yeah. This one that has what now? There's more space here, so it takes a longer time for the particles to what now? To collide. Do you understand? Yes, sir. So this block diagram will help you to remember that as what now? As pressure is what? It's reducing. What's happening to volume? It's increasing. Is that okay? Yes, sir. Thank you. Okay. We have said before now that if I have this two quantities that are inversely proportional, their product will give me what now? A constant. That is what? If they are directly proportional, their ratio will give me what now? A constant. That means if I have what? P times V, I'll get what now? A constant. Or you already know that if I'm going to change the sign of what? Proportionality to what? Equality, I must introduce what? A constant. V will now be equal to what? Q of P. So if I make K the subject, I'll get what now? PV. What does that mean? That what? Every time I have a pair of what now? Pressure what? And volume. Their product will be equal to what now? That of other pairs. E3 what? E3 and so on and so forth. Is that okay? Yes, sir. Thank you. Yes, sir. Okay. This is Charles' law. Charles' law states that the volume of a given mass of gas is directly proportional to its absolute temperature, provided pressure is what now? Is constant. If I was supposed to say this for boys' law, I just didn't remember. If I ask you how many things determines how any of this quantity affects, okay, what are the things that will determine the volume of what now? Of a gas. There are about 3 factors there that will determine it, but I'm sure you are seeing only 2. You are seeing only pressure and what now? And temperature, right? Yes, sir. A third thing that you're not seeing there is what now? Is what? Is mass. Did you get it? In place of mass, when we are doing the ideal gas equation, you will see what now? Number of what? Of moles. Because if you increase number of moles, you increase what now? The mass. I get right to say. Yes, so these 3 things will affect what now? Volume. The mass, the temperature, and the what now? And the pressure. So if you want to study the relationship between volume and what now? Temperature, we must keep mass what? Constant. We must also keep pressure what now? Constant. Are we together? Yes, that was just okay. Temperature is a measure of the average kinetic energy of what now? Of the body. I will need this definition to explain what I want to explain. You know, we have also been told that temperature is the degree of what now? Hotness or coldness of what? Of a body. Why do we say temperature is a measure of the average kinetic energy of a body? If you increase the temperature of the body, the particles will be more energized to move what now? Faster. Do you understand? I said something when I was talking about different things, gases, liquids and what now? And solid. That the particles of one move faster than what now? Than the other. Which one moves the fastest? Gases. Which one moves the least? Solid. So as you increase the temperature, what will happen? The measure of the average kinetic energy will also what now? Increase. Why do you say kinetic energy? Kinetic energy is energy for what now? For movement. So as you're increasing temperature, you're giving them more power to what now? To move. Are we together? Yes, so I just want you to remember that the higher temperature, the faster the particles can work now. Can move. How fast the particle moves tells us what now? Gives us a clue to the temperature of what? Of the body. Is that okay? Yes, Charles' law is a little more robust than what now? Than Boyle's law. Now, see the relationship I want to give between what now? Volume and what? And temperature. Considering what now? That pressure is what? Going to be what? Constant, right? And if pressure is going to be constant, we are saying that the rate of collision should be what now? The same. That means colliding at what now? The same rate. it's expected that because this space is what? Is small, the collision area of what now? Greater than what now? Than here. Are you getting it?
Yes, sir.
The only way that I can make the collision the same in this place and this place is to ensure that what? The particles here are moving what now? Slowly. Am I correct?
Yes, sir.
And these are moving what now? Fastest. I get what I'm saying?
Yes, sir.
If these ones are moving very fast, they can collide each other at the same rate that these ones will collide. These ones are moving what now? Slowly. Do you understand? So the idea of making the pressure constant is to increase the speed of what now? Of this one, and reduce what now? The speed of what? Of this. I already said that temperature is related to what now? To speed. So if this one is going to be slow, it means temperature will be what? Slow. I'm going to be fast. Temperature will be what now? High. Do you understand what I'm saying? So we see that what? Why the volume is small, temperature is what? Small. As volume what now? Increase. What now? If pressure must be constant, are we getting it?
Yes, sir.
Then the temperature must be what now? Must be high, so that the particles will collide at what now? The same rate, even if like this. So for Charles' law, this one will be a better what now? Way to what? To remember that as temperature is what? It's increasing. What's happening to volume? Volume is what now? Increasing.